Hi everybody, this is Mrs. Lehman, Math with Mrs. Lehman, you know the thing. Today we're doing Module 1, Ratios, Proportions, and Unit Rate for reviewing for Math Wizardathon 2019.
Hello!
So, these questions are from previous state tests from 2016, 17, and 18. So you guys could get a feel for what types of things you're going to see. The first topic we covered, and I forgot to start recording this, but shout out to Tara who's watching this from home right now. Woo! Alright, anyway, how to write a ratio. 3 formats. Ratio format, which has the colon, word format, which has the word to in between the numbers, and then we have fraction format. And as it says here, these can be scaled up or down to find equivalent ratios. So we can simplify them sometimes, or we can make them bigger. And we have to remember that the order of how ratios are written is very important. So after that, we did question 1. Simon used 3 pears to 9 apples, so we had the ratio of 3 to 9 for pears to apples in the fruit salad, which simplified to 1 to 3, choice A. I know I'm zipping through these quick. The next one, we had a basketball player. He's attempting 15 baskets, but he makes 9 of those. We want to figure out the number of baskets to the number, or the baskets he actually made to the number he attempted. So that's 9 to 15, a part to whole ratio, and that would simplify down to choice A, 3 to 5. Right? And now we're on Arnold's workout. So it says Arnold's entire workout consisted of 10 minutes of warm-up exercise, 25 minutes of lifting weights, and 15 minutes on the treadmill. What was the ratio of the number of minutes he lifted weights to the total number of minutes in his workout? So how much did he lift weights, guys?
25 minutes.
50. You guys got it? I said how many minutes did he lift weights? 25 minutes. It says right here, okay? 25 minutes of lifting weights. Everyone see that? And then we need to find the total. Right here it says total number of minutes of his workout. So total number, we've got to add them up. What do you think? 50. 50, very good. So again, you don't see the answer here. You need to scale that down. What would that simplify to, Abby?
1/2.
Very good. 1/2 or 1 to 2, which is choice B. All right, who here had choice B? Nice job. All right, so tonight you guys have homework. You're going to do question 4, which is about a ratio of kids on a basketball team, and question 5 for homework. We're going to do question 6 together right now. But before we do, the next section in our packet is all about ratio tables. So let's quickly review those. All right, one key thing that you need to know is that ratio tables it's just a table with a bunch of ratios that have been either scaled up, scaled down, or both, right? And all of the ratios are simplified to the same thing. They all have what we call the same value. All right? And it says the fractions can be simplified to the same fraction in simplest form. And you can look across to see what you multiply or divide by to get from one side of the ratio table to the other. Or if you look going up or down, a lot of times there's an additive property where you can say, okay, every time I add this number is getting added to the other side. Right? So let's take a look at some examples here. All right, so question 6 says the ratio of students to adults on a field trip is 8 to 1. Which table correctly shows this ratio for each grade? So let's underline keywords. What's important in there?
Adults on a field trip is 8 to 1.
Students to adults, 8 to 1. So let's think about this. Are there more adults or more students on the trip, Lorelai? More students. Let's take a look at these choices. Based on knowing that there are more students than there are adults, which one can we immediately eliminate?
B.
Choice B, very good. Notice it says that there's 104 adults and only 96 kids. That's a z-axis answer right there. All right? What other one doesn't really make sense? Tucker. A. Why does A not make sense? Very good. That ratio of 1 to 8, those numbers are far apart. And when you look at choice A, this is playing on a mistake that some kids might make if they're not being careful. They might say, okay, number of adults, well, I'm going to add 8, right? They added 8. That's not how we would look at that, right? We want to look for multiplicative going from one quantity to the other. So that leaves us with C and D. So we're looking for the one that's going to show a ratio of 8 to 1. The value of the ratio table is going to be 8 to 1. Which of these two actually works out with an 8 to 1 ratio? Evan?
C.
C. C. SC. It's very good. Correct answer. Choice C. All right. If you multiplied for choice D, number of adults times 8, you would not get 86. Or you would not get 96, you get 88, right? So that is incorrect. This one worked out. If you take the number of students and divide it by 12, you're going to get 8, right? You're going to get 8 students to every 1 adult. Any questions on that? All right, let's move on to the next question. Question 7. The table below shows how much money a grocery store receives for selling different amounts of asparagus. And it shows the chart here, asparagus sales. And it says if the unit rate is constant, what are the total sales for 12 pounds of asparagus? I'm going to pause the video. You guys are going to work this one on your own. So the kids did very well with this one. They got choice C, $30. So let me circle that and we'll scroll back up here. So,
Good morning, middle.
okay, so our internet's back, yay. So number of pounds for total sales 10. There's a few different approaches here. So what a lot of kids notice immediately is every time you jump up by 2 pounds of asparagus, you're paying $5 over here. The only thing I want to warn you of in this case is that every now and then they might say something like 9, right? And then a kid will add $5 for only 1 pound instead of 2 pounds. Does that make sense? You got to make sure the interval is consistent the entire way for you to apply that method. Another way is you could scale this down to 2 pounds of asparagus is $5, and then you could scale it down to 1 pound. You could find the unit rate of $2.50, right? So you take 6 times $2.50, 8 times $2.50, and that's going to give you this number over here on the right. Okay? So who here just use the additive kind of? Okay, a lot of kids did that. Did anyone find the unit rate and then multiply it that way? Okay, that is also a valid way. All right, let's move on to the next question. Question 8 is Kim Lee earning $2. Woo! In 2010, Kim Lee earned $17.50 for 2 hours of work. Make sure you have that underlined. That's very important. Which table shows the relationship between the number of hours worked and Kim Lee's total earnings? So number of hours and how much she made. And her rate per hour is constant, meaning she will consistently get the same amount of money for every hour she works. It's not going to vary as she goes. All right? So there is something that we can eliminate immediately. If we look at choice A, what makes choice A wrong? Liliana.
Because for 1 hour it says $17.50.
Very good. So this is an easy one to eliminate. Right here it says $17.50 for 2 hours. Right here it says 1 hour, right? So that's incorrect. All right, number 2. B. Well, it doesn't seem to matter how much she works. She's only going to get $17.50, which is not the case, right? So let's really look at C and D, which D ended up way down here somehow. So, which one's the correct answer? Abby? No, they're all in weird order here.
Well, I don't really know.
You gotta rethink it. Okay. Lonnie? D. D is the correct answer, right? So first of all, we're gonna check. It does say $17.50 for 2 hours, but that means every hour, if you take $17.50 divided by 2, you're gonna get $8.75, right? And up here, yeah, it says $17.50 for 2 hours, but then it's just adding $1 every hour, right? So that's not really at all what that said. So the correct answer is choice D. Now for your homework tonight, you're going to do question 9, question 10, so I'd be circling these in your packet, question 11, and question 13 we'll do here in a minute. But so you guys have a few that you need to practice on your own, okay? unit price is the next thing we're going to review. It says, what is the price per quantity of one? Example, 1 pound, 1 ounce, 1 item, 1 hour. This can be done using a proportion or through division. Okay, so let's take a look at an example. We've got this question, which is pretty easy. It says a grocery store sells a bag of 5 lemons for $2. I'm hoping you are underlining that right now. 5 lemons, $2. What is the unit cost of each lemon? So it's asking for the cost of only 1 lemon. There's an answer on here that does not make any sense. Which one does not make any sense?
A, $2.50.
Why does $2.50 not make sense, Rihanna?
Because it says that the 5 lemons cost $2.
Right, so you're not going to pay more for just one than you would for a whole bag of 5. So that is a garbagey answer, right? What other answer is kind of garbagey? Yes.
D.
Why is that a
Because-
trash answer?
Because if 10 and, I don't know,
10 cents times 5 would only, 10 is 50, I'm sorry.
it will.
Oh wait, no, not 50. Woo, start over, it's been a long day. 10 cents times 5 lemons would give you how much?
No.
10 cents. You have 5 dimes.
50.
50 cents, right? So that is not going to add up to $2. So which one of these is correct? If you take $2, divide it by 5, Cruz. B, 40, no, that's not correct. It's got to be
C.
C, okay? So again, you want to find the price per lemon. So you're going to take $2 and divide it by 5 lemons. All right, so you take $2 divided by 5. It's going to be less than $1 each, right? And that's going to give you 0.40, otherwise known as 40 cents. Another way you can set this up is with a proportion. So you start with what you know and you label. 5 lemons cost $1, right? We want to figure, $2. What am I doing? $2. All right, we want to figure out what is the cost of 1 lemon, right? So we want 1 lemon. To get from 5 to 1, we've got to divide by 5. 2 divided by 5 is 40 cents, as demonstrated right here. Any questions on how to find unit price? So you can set up a proportion, or you divide your money by whatever quantity, okay? So, number 13 is a question you guys have for homework. So 13, 14, 15, and 16 you're doing on your own. They all involve finding unit rate, okay? Why don't I have 17? Okay, I kind of have these out of order. I gotta fix it. It says Pat bounces a basketball 25 times in 30 seconds. At that rate, approximately how many times will Pat bounce the ball in 150 seconds? You guys remember this? What do we call that? Begins with a P, ends with
Percent out of 100.
Proportions, very good. So quickly to review, it's 2 ratios or fractions that are equal. Line equals line, I heard Paula say. It says look for the relationship from one side to the other to scale the ratio up or down to find the missing value. Start with what you know to figure out what you're missing. So in this case, back to 17, we know that he can bounce a ball 25 times, so make sure you're labeling this. A lot of kids make mistakes because they don't label. The expectation is that you label the quantities. So 25 bounces takes 30 seconds, right? We want to scale that up to 150 seconds. Where do I put the 150, top or bottom? Bottom, yeah, and it's easy to tell because, again, labels, right? So 150 seconds goes right down here. To get from 30 to 150, or to get from 3 to 15, what do we need to multiply by? By 5, good. So we need to take 25 and multiply it by 5. 25 multiplied by 5 will give you what? Think of quarters. You have 5 quarters. How many cents do you have? 125. Very good. All right, so again, proportion is line equals line. Include labels, and then you try to look for the connection, okay? I know you guys did some practice with that in a different class today as well. So anyway, we have to end this video for today because we are out of time. We're going to continue reviewing Module 1 concepts tomorrow. And don't forget to check out my review series to win some prizes and get some more review. Don't forget to like and subscribe. Have a great day.